All of you, I am Assistant Professor Kutte Akshada from SND Engineering and Research Center, Evla. Today's topic is classification of nanomaterials. Nanomaterials. Contents are introduction, what are nanomaterials, what makes a nanomaterials, classical examples, and then classification of nanomaterials. First, introduction. Nanomaterials are cornerstones of nanoscience and nanotechnology. Nanostructure science and technology is a broad and interdisciplinary area of research or development activity that has been growing explosively worldwide in the past few years. It has the potential for revolutionizing the ways in which materials and products are created and the range and the nature of functionalities that can be assessed. It is already having a significant commercial impact which will assuredly increase in the future. What are nanomaterials? Nanoscale materials are defined as a set of substances where at least one dimension is less than approximately 100 nanometers. A nanometer is 1 millionth of a millimeter, approximately 100,000 at times smaller than the diameter of human hair. Nanomaterials are of interest because of at this scale unique optical, magnetic, electrical and other properties emerge. These emergent properties have the potential for great impacts in electronics, medicine and other fields. These are the examples. The single wall carbon nanotubes, 1 nanometer diameter. Strand of hair, 100 micrometers diameter. House, 10 meters wide. What makes a nanomaterials? Different materials properties stem from among others. They very large contribution of surfaces and interfaces. Description at very small scale. Breakdown of infinite solid electronic structure. Size becoming smaller than some critical lengths, for example. Mean free path of electrons and phonons. Thermal conduction. Length of dislocation loops. Plastic deformation in metals. Critical defect size to intimate rupture. Brittle fracture in ceramics and glasses. Wavelength of light particle size. Classical examples. Nanomaterials are not new. Only the term is glass tainted with nanoparticles. Hardened aluminum alloys, anodizing aluminum, emerging steel, thick film resistors. Nanomaterials can come in bulk microscopic form. Classification of nanomaterials. Nanomaterials have extremely small size which having at least one dimension, 100 nanometer or less. Nanomaterials can be nanoscale in one dimension, 2 dimensions or 3 dimensions. They can exist a single fused, aggregated or agglomerated forms with spherical, tubular and irregular shapes. Common types of nanomaterials include nanotubes, dendrimers, quantum dots and fluorines. A major feature that discriminates various types of nanostructures in their dimensionality. Nanostructure material are low dimensional material as building units of nanoscale, at least in one direction and showing size effect on properties. We categorize nanomaterial as those which have structural components with at least one dimension lesser than 100 nanometer. Materials that have one dimension in the nanoscale and extended in other two dimensions are layers or coatings or films. Example, computer chips. Materials that are nanoscale in two dimensions and extended in one dimension are the nanowires and the nanotubes. Materials that are nanoscale in 3 dimensions are the particles. Example, precipitates, collides and quantum dots. Common types of nanomaterials includes nanotubes, quantum dots and fluorines. Nanomaterials have an application in the field of nanotechnology and displays different physical chemical characteristics from normal chemicals. Silver nano, carbon nanotube, fluorine, photocatalyst, carbon nano and silicon. Nanomaterials are materials which are characterized by an ultra-fine grain size or by a dimensionality limited to 50 nanometer. Nanomaterials can be created with various modulation dimensionalities as defined by Richard V. Siegel. 0 clusters, filaments and cluster assemblies, 1, 2 and three as shown in the figure. One is multi-layer, two is ultra-fine grain over layers or buried layers, and three nanophase materials consisting of nanomaterial size grains. According to Siegel nanostructure, materials are classified as zero-dimensional, one-dimensional, two-dimensional, or three-dimensional nanostructure. In zero-dimensional nanostructure, the nanomaterials have all dimensions within nanoscale range and larger than 100 nanometer are the zero-dimensional 0D nanomaterials. Examples are particles, quantum dots, or hollow spheres. 0D quantum dots are extensively used for LEDs, solar cells, lasers, etc. The 0D nanomaterials can be crystalline or polycrystalline, can be amorphous or crystalline, and can exist individually or in a matrix. First, first diagram is 0D spheres and clusters, that is zero-dimensional nanomaterials. Second, one-dimensional nanomaterials. These are the nanomaterials having grown along one dimension beyond nanoscale. Example, nanowires, nanorods, nanotubes, nanobelts. The silicon IC industry relies upon thin film for their operation. The monolayer are used in chemistry. The 1D nanostructure material are very important as they have wide range of potential application. These are the ideal systems for exploring large number of phenomena at nanoscale. The B is a structure of 1D nanofibers, wires and rod. These are the examples of one-dimensional nanomaterial. Then two-dimensional nanomaterials. Two-dimensional nanomaterials have two dimensions outside the nanoscale. Example, carbon nanotubes, nanoplates, nanosheets. 2D two, two-dimensional show unique shape dependent characteristics and subsequent utilization as building blocks of key components of nano device. They are important for sensors, photocatalysis, and nanoreactors. Carbon nanotubes are either single wall or multi-wall. Carbon nanotubes are few nanometers in diameter and microns to millimeter in length. Third number structure is the 2D film plates or network. These are the example of two-dimensional nanomaterials. Last, three-dimensional nanomaterials. Three-dimensional nanomaterials are the bulk nanomaterials which are not confined to nanoscale in any dimension. Example, fullerenes disperse of nanoparticles. Fullerenes C60, C540, C70 are important for miniature ball bearing to lubricate surfaces, drug delivery, vehicles, and in electronic circuits. These materials are characterized by having the three dimensions above 100 nanometer. These materials possesses nanocrystalline structure or involve presence of features at nanoscale. The behavior of 3D nanostructure depends upon size, shape, and morphology, which are the key factors of performance and applications. These materials have large surface area for enough adsorption sites, and if with porosity, then used for molecular support. Then D structure is 3D nanomaterials. These are the example of three-dimensional nanomaterials. Thank you.